Okay, so today we will talk about the pseudo force. Pseudo basically means false, okay? False or imaginary force. So then you can ask why, if the force is false, why do we have to study about it? So, what is so in today's lecture, we will understand why there is a necessity of pseudo force in physics. So before getting into pseudo force, the first thing you need to understand is frame of reference. What is frame of reference? So to define it, it can be called as a set of coordinate or system of objects that are used to measure and describe the positions and motion of the other objects. So this will not give the clear picture of what frame of reference is. So let's look into this example to better understand what frame of reference is. So here I have made a train in which of this person. Let us call this person to be B, person B, and here one of the person who is sitting at the platform is the person A. So if you see, then you will notice that this train is moving with a velocity of 20 kilometer per hour, and we consider the person who is sitting at the platform to be at rest, so whose velocity is basically zero. Okay, so if he makes any observation, so his x-axis and y-axis will be in this way. We can draw the coordinate system in this way, and you will know that this coordinate system is also at rest because this person who is making the observation is at rest. Okay, so but if the person B makes any observation, you know he's inside the train who is moving with 20 kilometer per hour velocity. So therefore, for any coordinate system from which he makes any observation, that will also be moving with the velocity of 20 kilometer per hour. Okay, so the point from where the person A is making any observation at this point, so this point is from this frame of reference which is also at rest, but this point from where this person B is making any observation, his frame of reference is also moving with him with the velocity of 20 kilometer per hour. So different, so if I put another person out here who's the person C, okay, so then for B, the person who is sitting at C will look like as if they both are in rest. So B will calculate the velocity of C to be 0. Okay, and same if the C does any calculation for the B, and then he will say the B is not moving, so because they are not moving with relative to each other. But if this person who is sitting at the platform, if he makes any observation, then he will say that B is moving in the east direction with the velocity of 20 kilometer per hour, or okay, and he will also say that C is also moving in the velocity with the velocity of 20 kilometer per hour. Okay, so and if B makes any observation for A, so then he will say that A is moving in this direction, west direction, with the velocity of 20 kilometer per hour. Okay, so you can see there is the same scenario, just when you make observation from different point, you get different answers. Sometimes you get 0, sometimes you get 20 kilometer per hour, and sometimes you get different directions as well. Okay, so this, the point in the space from which we make our observation, plays a role in this part. So these sets of coordinates, okay, are called a frame of reference, and some frame of reference can be moving, some frame of reference can be at rest. Okay, to further understand this frame of reference, we can classify this frame of reference into two main type of frame of reference. We call it as inertial frame of reference. Okay, and the second type is non-inertial frame of reference. But to start with, what is inertial frame of reference? So non-accelerating frame of reference is known as inertial frame of reference. So that means a point from where you are making an observation, if that point is not moving, if you are not moving, if you are at rest, if the velocity is 0, so then that frame of reference will be non-inertial frame of reference. Or if the velocity, if you are moving with a constant velocity, say 20 kilometer per hour, and if it is not changing with time, so then you are moving with a constant velocity where acceleration will be 0, because acceleration is rate of change of velocity. So if there is no acceleration, if you are moving with constant velocity, also then you can call your frame of reference to be inertial frame of reference. So the two important part you have to, 2 points you have to understand from the inertial frame of reference is these frame of reference are non-accelerating. Okay, important. So, and if you make any calculations in this from this frame of reference, the Newton law will always work. So that means Newton law will hold true. Okay, so if we go back to our example, if you see if this person is at rest, so that means the point from where he's making an observation or his frame of reference is at rest. So then we call this frame of reference to be a inertial frame of reference. Okay, so let's now move on to non-inertial frame of reference. Okay, so here one more thing, you both the cases, if the object is at rest or if the object is moving with constant velocity, in both cases there will be acceleration will be zero. That is why it is called non-accelerating frame of reference. But to move on to the second part, which is your non-inertial frame of reference, so in this case your frame of reference will be accelerating. Okay, so and in this frame of reference, Newton law does not hold true. Okay, this is the important point which you have to understand, that in non-inertial frame of reference the Newton law will not hold true or will not work. Okay, so this means that the velocity by which your Cartesian coordinate system is moving is not constant. So that means if it is going from initial velocity to some another final velocity, that means there is change in velocity, or we can say it is accelerating. So such type of frame of reference is called a non-inertial frame of reference. Non-inertial frame of reference. So that means if your frame itself is accelerating, so then such type of frame of reference is non-accelerating frame of reference. To understand with an example, you consider a person, okay, is riding a bicycle. Okay, so riding a bicycle, you will see that, or you will also see that the velocity of this person who is riding this bicycle is going to change from you. So sometimes you will have to increase your velocity and sometimes you have to decrease your velocity. So therefore there is acceleration. If this person makes any observation, so he is in which kind of frame of reference? He is in the non-inertial frame of reference. Is in non-inertial frame of reference. Okay, so now we have already done the free body diagram for an object which is in the state of equilibrium. Okay, equilibrium. So today we are going to make a free body diagram for accelerating body. So that means the body which is not at the equilibrium. So that means we cannot say the net force acting in this body is zero because it is accelerating. Okay, so let's see. I have already drawn, you see your mass is resting on this surface. Okay, and then it is accelerating in this direction with an acceleration a. Okay, and then you also know there will be always one force which will be acting downwards, which will be mg, and the upward force or the force which is normal to the surface is also called normal force n. Okay, so then if we have to write the equation for fx and fy, so you can see there is an acceleration in x direction. This is x direction, so there is acceleration in x direction, so we cannot say the summation of force in x direction is zero. So therefore it will be equal to mass time acceleration, because the force is given from the Newton's second law. We can write that force is mass time acceleration. Okay, but in y direction, you see the y direction there is no acceleration. Okay, in y direction the object is not moving, so then we can say in y direction the net force acting on the body is zero. Okay, so from free body diagram, so you will see that the force which is acting in x direction is only mass time acceleration. Okay, so this is the net force which is acting in this x direction, or we can say fx is mass time acceleration. And if I have to make for the y direction, so it is very simple. So y direction, so there is two force acting, fy and which is your normal force, and minus mg, because mg is in opposite direction. So we know fy is how much? Zero. So therefore we can write n minus mg is equals to 0, or n will be equal to mg. So these are the total forces, okay, acting on this body. Okay, so now we have understood how we can write or make a free body diagram for object or accelerating object. Okay, Now let's come back to our main objective. So to understand pseudo force, okay, so actually we were talking about pseudo force. So here what you have to understand is, uh, it depends. The pseudo force, we do not use it all the time, okay. The important part of the pseudo force which we discuss is that pseudo force is a false force. And for non-inertial, I have told that, inertial frame, I have told that Newton law does not hold true. So Newton's law does not hold true. Okay, so in non inertial frame, if you want the Newton law to work, so therefore then you have to use the concept of pseudo force. Then the Newton law will completely be applicable even in non inertial frame of reference. So let us see with an example, okay, and then you will be able to understand in more details. So now let's understand pseudo force. Okay, so consider a block of mass 2 kilogram out here. Okay, is tied with a string. Okay, on lift ascending. So this is an elevator. Okay, and this elevator is moving up with an acceleration of 2 meter per second squared. Okay, so our job is to find tension force. So tension force will be acting on this string and will also always be directed towards the support. So this is the support of the string, so the tension force will be acting upwards. Okay, now then we have to find the tension force from both inertial and non-inertial frame of reference. Okay, inertial frame is non-accelerating and non-inertial frame is accelerating. Okay, so now from two reference point we will calculate the tension force. Okay, so since we know this the mass is 2 kilogram, I can remove it from here. Okay, or I will slightly write out here, so 2 kilogram. Okay, so from let's first solve the tension force or find the tension force from inertial frame of reference. To find the tension force from inertial frame of reference, what I'm going to do is I'm going to make a free body diagram. So for free body diagram, you know that one force will always be acting downwards, and that is your gravitational force, which will be equal to mg, and another force is always already towards the support, which is your tension force. Okay, and now we have to choose our reference point. And what we are talking about, we are talking about inertial frame. So our frame of reference should be non-accelerating. So I will keep one person in the ground. Okay, the ground. So this ground is not accelerating, so therefore we can say he is observing from non-inertial frame of reference. So what he is going to see is, he will make a free body diagram. The tension force will be acting upward. Okay, he will be seeing that the mass is attached with the string, so the tension force will be upward. There will be one force will be acting downward with this mg, and one more thing he is going to see is this body is also accelerating in this direction, because this, the lift itself is accelerating in upward direction, so the elevator will be moving up. So then he will see there is a motion in y direction with an acceleration of a, which is your 2 meter per second square. Okay, so now let's do the calculation. Here what he is going to do, he is going to write the summation of force in x direction is 0, because you see the mass is not moving anywhere in x direction. But he will write the summation of fy is not 0, because obviously mass is moving in what direction? In y direction, moving upward, where acceleration is given by 2 meter per second square. So in fy he will write there is mass time acceleration. Okay, so from free body diagram, free body diagram, if he is going to write the equation for fy, so he is going to write t, and in downwards direction there is mg. Okay, and t minus mg will be equal to how much? Will be equal to ma. So our job is what? Our job is to find this tension force. So then I will take this mg to the other side. Okay, so that will give me t is equals to m a plus of mg. If I take m common, so this will be m a plus g. Okay, we have all the values, so therefore t will be, this is 2 kilogram. Okay, and then acceleration is 2 meter per second squared. Okay, so and acceleration due to gravity we will take 10 out instead of 9.8, so it will make our problem simpler. Okay, so this is 10 meter per second squared. So this is going to give 2 kg times 2 plus 10 is 12 meter per second squared. So now if you multiply, then you are going to get 24. So kg meter per second squared is basically Newton, the SI unit of force. So now from inertial frame of reference from ground, he calculated tension force to be how much? 24 Newton. Okay, so now let's move on to do the same problem from non-inertial frame of reference. Okay, so from non-inertial frame of reference, everything will be same. See, but now what the observer should be in something from a point which is accelerating. So I will place him inside this elevator because elevator itself is accelerating. So now he is in the non-inertial frame of reference. Now he will make if he is going to make a free body diagram, so then obviously there will be a force in downwards direction will be equal to mg. He is going to see the tension force will be towards the support, but one thing he is going to miss is that he will see this object to be at rest or equilibrium. Why? Because if the mass is moving upward, so this person is also moving upward, so therefore there is no change of position of this mass with respect to him, so therefore he will see this mass to be at rest. So then if he is going to write the equation for force, it will be Fx is equals to 0 because there is no motion in x direction. Okay, and he is also going to write Fy is also 0. Why? Because for him it is not moving in y direction also. Okay, because he himself is moving with this mass, so therefore he does not see any motion relative to him, so Fy will also be 0. The next thing that he is going to do is he is going to write the equation for Fy from free body diagram. From FPD, what he is going to write, summation of Fy is tension force in up direction and minus mg which is in down direction. So what is a summation of Fy? It is 0, so therefore tension force will be, okay, so tension force will be equal to T minus mg, which will be equal to 0 because summation of force in y direction is how much? It's 0. Okay, so the next thing is will be T will be equal to mg, and we have the information of mass which is 2 kilogram and acceleration due to gravity we are taking it to be 2 meter per second squared. So he found this tension force to be 20 Newton. Okay, so see the same problem when calculated from different point or different frame of reference, we got different answer. From inertial frame of reference we got 24 Newton, and from non-inertial frame of Newton we got 20 Newton. So non-inertial how much? Non-inertial we got 20 Newton and inertial we got 24 Newton. So therefore the problem is same and the answer is two different answers. Okay, so one is this and another this, so one of them has to be incorrect. Okay, so either this will be from non-inertial, it will be this incorrect, or either this from the inertial it will be incorrect. So after several experiments and several observation, what we found that the answer which we have or what we have calculated from inertial frame is always correct, and non-inertial frame it is incorrect. Okay, so therefore this 20 Newton is not the correct answer for this problem. Okay, or the tension in the string is not 20 Newton which we calculated from non-inertial frame of reference. Okay, so therefore if you have to get the answer of 24 Newton from the non-inertial frame of reference, then you have to apply the concept of pseudo force or false force. Basically there is no force as pseudo force, it is completely imaginary, but we have to consider it when we are making our observation from non-inertial frame of reference. So let us now see how the pseudo force can solve our problem. Okay, so now again the person has to be in the non-inertial frame of reference, so he will be placed inside this elevator. Okay, he is going to make free body diagram just like in the case of previous case. So he will write downward force is mg, the upward force is tension force, already written. So now one more thing he has to consider. If he knows that his frame from where he's taking the observation is moving upwards, okay, upward with some acceleration a, okay, it is moving upwards, so then he have to consider one force Okay, one force in the downwards direction, which we call it as pseudo force, or it is written as FP. Okay, so what we did, we know our frame of reference is accelerating in upward direction. Okay, so to counter it, what we do, we use one pseudo force, or we consider one force, pseudo force, which will be acting downwards. Okay, so pseudo force, okay, pseudo force should be considered opposite to the acceleration of non-inertial inertial frame. Okay, so that means if your frame is like this and it is accelerating in this direction, so then pseudo force has to be uh, uh, has to be this considered in the opposite direction. Okay, so now, and this pseudo force is again mass time acceleration only, and this acceleration is the acceleration of your frame, the acceleration of frame. Okay, this acceleration of frame, we use one negative sign because this acceleration of frame and pseudo force are always opposite in direction. So you see the acceleration is in upward direction, and we have considered pseudo force in downward direction. Okay, so then the next step will be, this person will consider this object in non-inertial frame of reference to be at equilibrium. Okay, so object should be considered to be in the state of equilibrium. Okay, so now let us see how we can solve our problem based on this information. Okay, so now he will write summation of fx is equals to 0 and summation of fy is equals to 0, because the object has to be considered to be in the state of equilibrium. Okay, so now what he is going to do, in x direction you see there is no force, so therefore he don't have to do anything for x direction. For y direction, what he will have to do is he will consider tension force. So from free body diagram, okay, so FBD is writing, so summation of Fy, tension force is in up direction, Mg is in down direction, will be Mg, and one more force he has to consider, that is your pseudo force, and pseudo force is given by negative of mass time acceleration. Okay, because you see this mg force and this pseudo force both are in same direction, so both are negative and opposite to the tension force. Okay, and he has considered this body to be in equilibrium, so we know that Fy is also 0. So using that concept, I can write T minus mg minus ma is equals to 0. So if I take ma and mg other side, so it will be mg plus of ma. Okay, so now this will give T is equals to mg plus a. Okay, and then finally it will give T is equals to m. Okay, so now we will use our values. We can know mass is 2 kilogram. We know that acceleration due to gravity can be considered to be 10 meter per second squared, and acceleration is 2 meter per second squared. Okay, 2 meter per second squared. So this will be 2, T is equals to 2 kg into, if we add this, we will get 12 meter per second squared. Okay, and finally if we multiply this two thing, I will get 24 kg meter per second squared. Okay, so this is the answer, and we have found this answer from where? From non-inertial. So non-inertial, if you are doing any calculation from non-inertial frame of reference, then you have to use what? Use pseudo force. So now you have understood what is the importance of pseudo force in physics.